So yeah, I'm Dakotah Lambert. I'm going to talk to you a little bit about function complexity. Basically, unlike Scott, I'm not dealing with real linguistic data. I'm just using algebra to talk about linguistic patterns in general. And so a large part of my research has been basically coming up with this nice hierarchy of complexity classes that we see. Basically, we talk about the regular languages a lot. If we're in CS, we've all heard of those. Things below regular don't really get a whole lot of look except in linguistics. And so we have all of these logically possible places where patterns can fall, and we want to know where do they fall, because that tells us a lot about the patterns. Tells us what we need in order to learn them, in order to recognize them, in order to produce them. What kinds of distinctions do we need to make? And so that's where the algebra comes in, is it lets us look at the structure of things and say, like, what kinds of distinctions are being made. So like this LT class that I'm pointing to over here, things are distinguished by the sets of subparts they contain. And so I've taken these classes and applied them not just to constraints, to sets of things, but also to processes, because those kind of behave in the same way. We can model each with a finite state machine, and those finitely many states give us the distinctions that we need. And I've just went through a whole bunch of patterns that show up in languages, like harmony patterns over vowels, like Finnish has this where front ö becomes back o in some contexts. And we can see that the space of logically possible patterns goes way off into the distance, super complex, even just restricting ourselves to the world of regular languages, regular functions. But all of the things that appear in linguistics seem to be well below that. And in terms of function complexity, before, a lot of people were just focused on saying, oh, well, we just need something that's below first order logic, which is true. First order is like way up here. But so I've now given us a much more, a broader place to classify things, and we get more information about our patterns this way. I think that's time. Thank you.
What does this complexity of, I guess, the language phonology, if I'm trying to get it right, have to do with the ability of the language to express information?
I don't know that it necessarily has anything to do with like semantic content. This is more about like how are words going to behave? What kinds of patterns within a word would you be able to see?
But would it have something to do with the length of an expression necessary, the length of a voiced expression necessary to express a certain amount of information?
I suppose depending on like your alphabet size, maybe. Like if everything is way down, like stuff indefinite can only be distinguished based on suffixes. And so, depending on how wide your suffix that you're allowed to care about is, you might need more words. But I don't know. Yeah.
Where would something like, where would a spoken language like English end up this kind of classification?
So a spoken language like English, if you're looking at the constraints that it follows, is going to be the least upper bound of the things that it contains, and so fairly low. If you're looking at the processes that make up English, well, that really depends on how you represent composition. If you want to say that we have a stream of things that are each of some complexity, and therefore it's that complexity, it's going to stay in this kind of region. But if you want to actually do the composition and say, where does the pattern as a whole fall, it might be higher.